Hi everyone, thanks for coming to listen to this talk. April 4th, 1975, two men ruined my life, not to be overdramatic. Their names were Bill Gates and Paul Allen. They co-founded a little company called Microsoft, you might have heard of it. And I hear you saying, well Matthew, what could you possibly have against Microsoft, Bill Gates and Paul Allen? And I'll tell you, it's SharePoint. At the very start of my career, I was working for a Microsoft partner on a project that made heavy use of the Microsoft stack, SharePoint, Microsoft Dynamics CRM, Windows Workflow, C#, .NET. It took weeks to deploy, on-premise, I might add. Nobody really quite knew how it worked because there'd been so much turnover, and really it scarred me for life. And I said to myself at the time, I will never work with the Microsoft tech stack again. Fast forward to last year, we were kicking off a new project for an American health insurance company. And at the start of any project as a consultant, that's a tense time because you're chatting to a new team. They've made some decisions. They have their own preferences. You have your own preferences about how you like to do things. And essentially your fate is being decided for the next year, 2 years, or whatever. We had a typical call with the director of engineering to chat about what they wanted to build, the architecture that they were going for, and the tech stack that was going to be used. And it all started so well. First of all, they were going to use AWS. That's amazing. Love using AWS. Check for that one. They were going to go with a serverless first approach. Good job. I didn't need to explain to them what a serverless first approach was. We could just not waste time doing that and just get down to business. And then he says, and we're going to use .NET. And I says, yep, that's great, absolutely. Hold on a second. Did you just say that we're going to use .NET? You see, we can't do that because Microsoft made .NET, they made SharePoint, and this can't be happening to me. But the client was adamant, .NET it had to be. Now his argument was this. His argument was that in the health insurance space in the States, he would find it really easy to hire developers with the necessary expertise in the health insurance industry, and they were going to have the .NET experience as well. I have no reason to think that he was lying to me, but he is also a huge .NET fanboy, and that might have been the actual reason. But when you're consulting, that's the reality. Sometimes the right choice for our customer isn't necessarily the choice that aligns with your own preferences. The best engineers can adapt and get over their own preferences and deliver value for their customer or our customers. And I'm glad we did. This was a great project to work on. It would have been a wasted opportunity if I had to say, well, I'm not going to work on that because they're using .NET. My name's Matthew Wilson. I'm husband to Rebecca, father to Joy Tabitha. I'm a distinguished engineer at Instill Software. We're a product development and cybersecurity company based in Belfast. And I'm an AWS community builder and user group leader in Belfast. And I'm also a beekeeper, just in case you think I like to dress up like that for fun. And yeah, if you want some honey, come talk to me afterwards. And today we're going to ask the question, can you find joy in serverless.net? And we're going to look at 4 things. We're going to set the stage. We're going to look at safety without sacrifice, the simplicity of the ecosystem, and how you can soften the blow with generative AI. And maybe we'll answer the question, have I forgiven Microsoft after all these painful years? So let's set the stage. As I already said, this was a health insurance platform for a startup in the States. They had nothing, so we were building this totally from scratch. It was the greenest of green fields, you could say. And at a very high level, they asked for a few things at the very beginning. They wanted to build a data lake, and they wanted us to build this operational layer with some front ends on top of that. The data lake itself was a serverless data lake built with S3, Glue, and Lambda, Python being the programming language of choice there. And they were really aiming for a nice separation of storage and compute. An important thing to note about the data lake itself is that this was the integration point for our system. Through a separate AWS account, we were consuming data from a lot of different vendors. That was then being streamed into our data lake and going through a medallion architecture from bronze, silver to gold, with gold really being that refined layer. Where I spent all of my time working was in the operational layer. This was a serverless backend in AWS using AppSync, Lambda, DynamoDB, and a few other things obviously sprinkled through that as well. This was a stack that's very familiar to myself and my colleagues at Instill. And any other customer, any other day, we would have went with TypeScript for that operational layer. We've got lots of experience with TypeScript. Everybody loves using it. Performance with TypeScript and Lambda is acceptable for most use cases. That single programming language, front end, back end, infrastructure as code, if you're using CDK, means that you have a single language that people can get good at. They don't have to context switch between different things. And as full stack engineers, that's just one less thing to have to worry about. And that's my own personal reason for loving TypeScript, and I really just pretend that it wasn't created by Microsoft. But unfortunately, we were stuck with .NET in this case. And I was quick to point out that when you're using .NET with serverless and AWS, it's one of the slowest runtimes available with Lambda. I'm sure some of you are familiar with this GitHub repository, the Lambda perf repo. It benchmarks all of the Lambda runtimes on a regular basis and publishes a report so you can see what's the cold start time like, what's the memory usage like, and what's the average duration like for any given runtime. And the screenshots on the screen show the Node.js runtime and the .NET 8 runtime. And if you look at, first of all, the first number with the little snowflake beside it, that's the cold start time. So you can see that the .NET 8 cold start time is roughly 100 milliseconds more than Node.js. Memory usage is comparable, a few megabytes, you're not really going to worry about that. But the average duration is significantly worse, from 12 milliseconds for that Node.js runtime to 677 for the .NET 8 one. And what that's actually measuring is just a simple hello world Lambda function. And this is the sole reason I think that .NET is ruled out of many serverless projects, because the performance just isn't acceptable for most use cases. If you had a .NET 8 Lambda function on the request path, those 600 milliseconds are going to be noticeable if that Lambda's starting from cold. But there are pros and cons to any technology choice. I'm not here to say that, I don't want you to walk away from this talk and think that he's going to say JavaScript and TypeScript is better than .NET. That's not the point of this. TypeScript has its own issues, okay? One thing I've seen happen too many times is that, especially with inexperienced engineers, they assume that because you have TypeScript types, that they exist at runtime and you have some kind of runtime type safety. And you can get caught out with a bug that just wouldn't happen in a language like C#. And if this is brand new information to you, just very quickly, the reason is that TypeScript is transpiled into JavaScript. All of its type annotations, all the nice interfaces that you've written, all the utility types that you've used, they're totally erased in a process that's called type erasure. And when that TypeScript Lambda function is executing on AWS Lambda, it's running in a JavaScript runtime, and it's just running that transpiled JavaScript. There's no type checking. Your type errors with TypeScript happen at compile time. That's during development, not when it's actually running. Libraries like Zod can really help bring you back some of that runtime safety that you might want. But it's nice to not have to worry about that with a language like C#. And as a simple example, if we take this piece of TypeScript here, we have an interface for a person which has a name and an age. And we fetch some data from an external source. As you can see in our interface, we expected that age to be a number, but it's actually coming through in the JSON as a string. And if you were to then, this is obviously a very simple example, but if we were to increment that age, what would actually happen is that would be now 301 rather than what we expect that to be, which would be 31. If you have no control over external data and it's coming into your system and you've made an assumption like this, then this is a bug that's just waiting to happen. Now, there's two things I need to stress before you come and shout at me after this talk. This problem isn't just solved by using a language like C#. And if you're a TypeScript expert, you're also not going to be caught out by an error like this. But the point I'm trying to make here is that a strongly typed language like C# with runtime safety combined with a compute model like AWS Lambda is an excellent choice. But we still have this issue with performance. If the latency is so high that the application itself suffers for the end user, and really that nice type safety isn't really worth it. So how can we get safety without sacrificing that performance? And thankfully there is a way as of .NET 8. Ahead of time compilation was added as part of .NET 8. This is a compilation approach where your code is compiled ahead of time, which is AOT, to native machine code before the application runs, rather than at runtime. If you were to use a non-AOT Lambda function, let's say, what you're doing there is JIT compilation or just-in-time compilation, and that's happening as the Lambda itself is running. So if you eliminate that just-in-time compilation step, it results in faster startup times and less memory usage as well. Those two things combine together to reduce that cold start time and average duration for your Lambda functions, resulting in a much better overall performance. So if we bring back our two examples from before, Node.js and .NET 8, non-AOT, let's call it, and then bring in an example benchmark of using .NET 8 with an AOT compiled function, you can see that it is significantly faster than Node.js itself. The cold start time is only 89 milliseconds, and the average duration is, again, like very comparable to Node.js. And I don't know about you, maybe you're all .NET experts. I'm not, as I've said. This was a huge surprise to me. Being able to use a beefy language like C#, a really mature language with a lot of really good benefits, but then be able to combine that with Lambda and get performance that is acceptable. If we're saying Node.js is acceptable, well, this should be even more acceptable because it's even faster. That was amazing. But like everything, there are a few catches, there's a few gotchas with AOT compilation. And there's two that I want to talk about. And some of these are easy to solve, and some of them can be really difficult to solve, depending on how mature your project is. So the first of all is there's no cross-architecture support. And this is best explained with an example. If you wanted to deploy your AOT-compiled Lambda function using Graviton, so using an ARM processor, then you need to compile that using Amazon Linux 2023, which is the operating system used in Lambda, and an ARM processor. So for us, like obviously I'm using an M-based Mac here right now, so I can easily do an ARM compilation. And there's tooling that the teams at AWS have provided to pull down a Docker image with containing Amazon Linux 2023, copy all the code onto that, do the compilation, and then it spits out a zip file that you can then just deploy into AWS using Terraform or something like that. So like I said, that's relatively easy to solve. This caught out an external contractor in one of our teams who was using an Intel Windows machine. And he really then was deploying x86 Lambda functions, which are different than what we're using in production. And most of the time that's probably going to be okay. But there's a chance that he could work on a feature and it might work just fine, but have some weird bugs if we were to do something on a different architecture. Probably going to be okay, but it's just something that we would rather everybody was just doing the exact same compilation and deployment process as well. The biggest catch, though, comes down to serialization, and it's quite a surprising thing to catch you out. Serialization with an AOT-compiled Lambda function is incredibly painful, and this is because of how AOT works. As part of that ahead-of-time compilation step, there's a process called trimming, which trims away a lot of metadata that's not necessary for the native machine code. So it tries to reduce as much as possible. And that eliminates all of the metadata that is used for reflection. And probably the biggest serialization library in the .NET space is called Newtonsoft JSON. It's entirely based on reflection, so it just doesn't work with AOT. It's got like 6 million or 6 billion downloads in NuGet, so it just totally dominates the .NET landscape. And if you try to pull in a third-party dependency that uses Newtonsoft JSON, then you can't use it with an AOT-compiled Lambda function because it simply just won't work. So what you have to do is review the packages that you want to use in your function. And if they are AOT compatible, then that's fine. That's a very easy decision. If they're not, then really you can't use it. And that's a real shame because a lot of, this is obviously a very niche part of .NET that's not used by everybody. It's really just useful for things like Lambda. So people aren't really motivated to try and change to the other solution, which is called source-generated serialization, where all of the code that you need to perform your JSON serialization and deserialization is generated at compilation time. So I think there's really a few decisions you need to make there, like I said. If you're starting from scratch like we were, then it was relatively painless for us to adopt AOT. As I said at the start of the talk, our integration point was at the data lake, so we really didn't have a large dependency footprint. This was just a happy accident, to be honest. It wasn't something that we thought of up front, but it worked out really nicely where we were able to use AOT Lambda functions for essentially every function in that operational layer, and any integrations with other third parties was all done in that Python layer instead. If you have an existing .NET project, then it's going to be a significant piece of work to migrate to an AOT Lambda function. In that case, then, what I would suggest is look at things like SnapStart instead, where it takes a snapshot of that just-in-time step. So a lot of that work has been done, and then loads that from a cache instead. And that's just another another feature of Lambda that you can use to try and get the best performance with a language like C# and .NET. The issues of the architecture, the no cross-architecture support, that's a problem that's been solved with tooling. And on the topic of tooling, that's one thing that was really positive from this project. The teams at AWS have done a lot of work to make the tooling as seamless as possible. And I have no real evidence of this, but I'm just going to say it because I think it's true. AWS have an uphill battle trying to convince .NET developers to use AWS. Like if I was a .NET developer, I would just use Azure because the two things are made by the same company. So I think AWS have put a lot of work in to make the tooling really nice to use because they're trying to encourage .NET developers to come to a different platform. And we really benefited from the tooling, like the stuff for doing the AOT compilation. Like it just worked. It wasn't difficult for us to set up and really reduced the friction for us as we were trying to learn how to get the best out of this technology. So the simplicity of the ecosystem, like I said, great tooling, the .NET CLI. There's a lot of blueprints that you can add to Visual Studio Code or Writer. And there's a tool called the Mock Lambda Test Tool, which we'll talk about a little bit later on, but it lets you run your .NET Lambda functions locally, which is amazing for testing them out and reducing that development lifecycle. And secondly, you have PowerTools. If you're not familiar, there's an open source library called PowerTools for AWS Lambda. It has a lot of features for Python and TypeScript, but they've also added quite a bit of functionality for .NET as well. And we use it for things like tracing, metrics, loading in parameters and secrets, batch processing utilities. And really, the reason why we like it so much is that we have developers coming from a TypeScript project, and they have a lot of experience using PowerTools. And they get this consistent, a suite of libraries that are used then for things like tracing and metrics, like I said, and logs. So that just helps, again, just eliminate that burden on our teams when moving between a .NET project and a TypeScript project as well. If you're not using PowerTools with Lambda, I would recommend checking it out. Like I said, there's a lot of runtimes that support it now, and they're adding new functionality all the time as well. Thirdly then as well, being able to use ASP.NET with Lambda. There's a package on the screen there, ASP.NET Core Server. This allows you to run an entire ASP.NET API in a single Lambda function. And there's a number of benefits to this approach versus creating like a function per route. I call this a single function API. You might have heard other people call this things like a mono Lambda. And there's quite a few benefits to this architectural approach, let's say. Firstly, it's simpler. You don't have multiple functions to go and look at for any given API. You have a single function that you can go look at. You don't have to go look at your routing configuration in infrastructure as code, try and map that to a single Lambda function and then work out the flow there. You know that if you're working with the example on the screen here, like a user service, that there's going to be one place in your code base where you can go and look at how that is packaged, how that works, and also how that's deployed. It's deployed as a single unit. Having that single Lambda function as well is another way of reducing the latency of your API. So we've got AOT, we've got SnapStart, but we've also got this approach as well. If our user service in this example was incredibly busy, this Lambda function is never going to go into a cold state. It's always going to be warm. So really having that AOT compiled is no benefit. That could be just a normal .NET 8 Lambda function that isn't going to suffer any performance penalty because it's already in that warm state. So again, another technique that you can use to use a language like C# with a compute model like Lambda. Another benefit to being able to use ASP.NET is that you can just run it locally. The tooling, if you're using Writer or if you're using Visual Studio Code or whatever, the green play button in your IDE just works. You can start it up locally, hit it with Postman, and get all of the benefits of local development without having to package this up and deploy it into AWS. That AOT compilation step takes quite a while, so that would really slow you down if you had to compile, deploy to just test something. I used to be of the opinion that this was actually a bad thing, like running your Lambda function locally was something that we were discouraged from doing. You may have heard the phrase, bring the developer to the cloud rather than bringing the cloud to the developer. But what I've sort of learned in hindsight is that we really need a mix. There's a really nice approach and a really nice flow you can get into where you make your changes locally and test them, then deploy them into AWS and test them in AWS as well. The reason for that is that you get to test your permission and things like that too. This, in my opinion, is the best way to start building APIs with Lambda. Start with a single function that routes and handles the requests internally. Easier to deploy, easier to reason about, easier to test and debug. There may be times when it makes sense to split this up, but that's an optimization that you can make in the future. Don't start with 3 Lambda functions in this example. Start with 1, and when it becomes a problem, if it ever becomes a problem, then break it up. If you are not using ASP.NET, if you're using TypeScript or Flask or some other, or Express, any other kind of web framework, there's an open source project called the AWS Lambda Web Adapter. This allows you to run a whole bunch of popular API frameworks in Lambda, things like Next.js, Flask, Express, like I said. So not only do you get this, this allows you to get that same kind of ASP.NET style, but with something else if you're obviously not using .NET. After a few months on the project, then we gotten into a really good state. We had delivered quite a few features. We proved that our architecture was going to work for them, and we'd gotten to grips with using .NET on AWS. But like I said, that development cycle was far too slow. Developers were compiling locally, having to do the deployment and push to AWS for testing, and that was getting really painful. And this is where we wanted to make sure our local development setup was as best as possible. I wanted to take some time and improve the developer experience where folk could just run a simple script and then run the entire application locally. And when you are on a busy project like this, things like that can be set to the wayside. But I think there's a real opportunity to soften the blow with generative AI. If you've ever had a conversation on your team that starts like this, wouldn't it be nice if, and then straight after that, somebody says something really cool or insightful that actually would be really nice for your project, but then you say, oh yeah, but we'll never have time to do that, or maybe someday we'll get to that, or put it in the backlog and we'll look at that in a couple of weeks' time. I think these wouldn't it be nice if conversations is a really good opportunity to put generative AI to work. You might feel bad using your own time to solve one of these problems, but you shouldn't really feel bad if you're wasting Copilot's time trying to solve this problem, which is exactly what we did. Wouldn't it be nice if we could run everything locally without manual configuration? What I mean by manual configuration is, in Writer, we were running Lambda functions, but you had to copy your access keys into environment variables, and DynamoDB table names into environment variables, S3 bucket names into environment variables. But a script that would just set all of that up for us in Writer, where we could just run every single microservice all at the same time, but have them talk to remote resources in AWS, was really what we wanted. So we used GitHub Copilot to solve this. We asked it to write a bash script that would do all those things I just said, pull in the Terraform output of all of those names of resources and things like that, generate the necessary run configurations that would work for Writer. A colleague of mine has also then, since I've moved off this project, has done the same for Visual Studio Code, so we can use both IDEs depending on the developer preference. And it sets everything up where the green play button in your IDE starts everything locally. This gave the team a script that would just, they could just use Postman to test API changes. They could use that Mock Lambda Test Tool that I talked about to test things like S3 event triggers. And really just being able to debug in your IDE just really saves a lot of time versus having to look through CloudWatch logs and things like that. I think we can use generative AI for quick wins like this. It's a really good place to start getting to grips with these kinds of tools where you're using an agent to make changes to code that's not really going to make it into production. Help develop that skill set and strengthen your team's ability to use these tools. And then you can then start to use those skill set elsewhere for delivering features to the application itself. So is there joy in serverless.NET? Has this project healed the deep, deep wounds caused by SharePoint? It pains me to say it, but it actually has. That safety without sacrifice is incredibly valuable, especially if you have an inexperienced team. The simplicity of the ecosystem, I think having less options actually sped up our decision-making process. There's only really one way to deploy an ASP.NET Lambda function. We didn't have to have any debates about it. We just started building instead. Soften the blow with generative AI. Look for ways to adopt it into your development workflow beyond just autocomplete. There shouldn't be death by 1,000 cuts anymore, now that we have ways to quickly solve simple tasks that are maybe avoided due to time constraints. Maybe time has healed those wounds caused by SharePoint, or maybe I've learned that we shouldn't let personal preferences stand in our way of progress. Our goal isn't just to write code, our goal is to deliver value to our customers and our clients. People don't really care about the programming language that we're talking about here today. They just care about the software actually working for them. Yeah, thank you. If you want to connect with me on LinkedIn, you can scan this QR code, and I'll be around for any questions afterwards as well.
That was a wonderful presentation. Do we have any question?
Surely Dynamics is worse than SharePoint.
They're all bad.
This is my experience.
You were talking about AOT. Do you have examples of using any other file formats, like say like CSV, with ahead of time compilation?
No, I mean, what do you mean by CSV? Sorry.
You know, like you serialize different types of data, and you were saying that AOT struggles with serialization.
Oh, sorry. Yes. No, we only were parsing JSON, so I have no experience. I mean, that would all just come down to how, if you were to pull in a library for parsing a CSV file, it purely depends on how that works. If it doesn't use reflection, then it'll work just fine. And like I said, like the big issue there is around Newtonsoft JSON, which obviously wouldn't do anything for CSV. But yeah, that's just something that what we started to do if we wanted to pull in a dependency was just look at the dependencies it used. And if it used Newtonsoft JSON at all, then you know like this is not going to work. There are ways, like there's things you can do where part of a package might be incompatible with AOT, but you can just ignore that and not use it. Like there are ways around it as well. But that, like I said, that's probably the worst part of this, is that having to do that auditing of dependencies is awful, really. You know, it's something I have to spend time doing. It'd be amazing if, you know, all like open source, you know, projects would just adopt AOT as well. But like I said, nobody's really motivated to do it unless you're looking to use Lambda. There's probably other use cases as well for AOT, but you know what I mean. It's fairly niche, I think.